AWS introduced Model Context Protocol for AI tools. AWS MCP helps you with CDK infrastructure, documentation, knowledge base, cost optimization, and other AWS stuff. Today I'm going to connect AWS MCP to Cursor IDE, and we will see how it improves your work with AWS CDK resources. Let's start. So, what is MCP, or Model Context Protocol? In short terms, it's just like an API for your AI tool. AI tool, or for example Cursor IDE, sends JSON with a request. Your MCP server gives specific information for your AI tool, and it's not guessing, it's using this information for more deterministic output. For example, if we think about AWS, AI tool can request current prices for specific infrastructure. AWS MCP server will respond with prices, and AI will use them for your output. Let's dive right in. First, we go to AWS Labs website, and here we have MCP service documentation, and we need first of all core server, and additionally what I'm going to show you today is CDK server, which is this one. What you need to do, you need to copy these blocks, and then I will show you how to set up them in your Cursor IDE or other IDE which support actually MCP server. So in your Cursor IDE you click settings, Cursor settings, and you go to MCP. As you can see, we already have MCP servers installed because I did that before the video recording. But what I'm gonna show you, you just click on edit, and here you can see all the settings which I copied from MCP webpage and pasted here. In this video we will want to enable core server and CDK server. Now your Cursor IDE can use MCP server, but for now I will disable it, and I'm gonna demonstrate you how it works without MCP and then how it works with MCP. I prepared a little prompt. This prompt asks to create AWS CDK stack with a Fargate SQS handler. This handler runs Fargate task, pulls messages from queue, and processing them. Let's try it out. So, our Cursor created CDK stack. Let's look what we have here. So we have Fargate stack, VPC created, we created main queue and dead letter queue, we created Fargate service, task definition, container definition, service definition here, auto scaling, scale on CPU, and what I'm mainly interested in is Fargate connected with SQS. Let's look at that. So we don't have any specified connection, but we have role to allow get messages from SQS queue, grant consume messages. So what we're gonna do now, we're gonna try to do the same, but with MCP enabled. We should go to Cursor settings, MCP, enable core server and CDK server. Now what we're gonna do, we're gonna run same prompt again, but on a different folder. I'm gonna clear this out. I imported another folder, same prompt. So Cursor agent finished generating Fargate CDK code. Let's see what do we have here. And as you can see, it's much smaller output. We have only 20 lines of code comparing to around, I would say, 100 lines. Let's compare it side by side. And here we see that we only imported one class, which is Fargate to SQS. It's using existing AWS constructs, which is a pattern, and inside it contains actually similar code to what we have here, something like creating SQS queue, creating Fargate service, mapping it one to another. As we can see, it has a lot of properties which we can use. We can put 10-letter Q, we can put Q here, and under the hood it has, let's say, same or similar functionality as we created on the right side with all these 200 lines of code. This is actually benefits of using AWS MCP server, because it will help you with utilizing latest solution, latest documentation, latest infrastructure, existing patterns, so you will have a more robust, more readable, cleaner code. You will have latest infrastructure and documentation. What I also wanted to show you is how MCP works under the hood. Here we can see that Cursor agent called AWS construct pattern. We see the request. Request is a JSON which contains services which we need for our CDK infrastructure. And we have result. Result is pattern name, service, description, how to use it, which repository to use, and a lot of other patterns which can be used by our agent. So this is really cool, because this is deterministic for agent, and it's not guessing output as usually LLM does, but it's actually really using AWS documentation, constructs, packages. Everything is up to date. Another cool thing which I wanted to show you today is that how we actually can calculate our costs. So here you can see I put some small prompt that we want to calculate costs for 10 million messages per month sent to SQS. Each message will be processed for 1 minute, CPU required 4 CPU, and I consistently asked to use MCP server because, to be honest, sometimes Cursor agent is skipping it and just trying to do things without calling MCP. And here we see that we called MCP server, we received output, agent called it several times with different kind of requests. Here we see pricing model on demand, some description. We see also some information as parameters, and what we have down, we have detailed estimation for our services, and we see that totally 10 million messages with parameters like ours will actually cost this amount of money. And if we break it down for SQS versus Fargate, we can see that we mostly will pay for Fargate containers. So that's really cool, because we can calculate the cost of our infra without going to AWS pricing calculator. We can just ask Cursor, connect it with our code, and receive detailed cost estimation. AWS MCP works under the hood. Our Cursor IDE makes request to core AWS MCP server. That server decides where to forward the request. So we have several servers like CDK and cost server, which we actually seen today. And then these MCP servers calling actually AWS API, for example, API like cost estimation, etc. And Cursor IDE then receives a JSON response with detailed information about AWS resources, cost, documentations, etc. That's it for today. I will put all the links to the description of this video. Please hit like, subscribe, and leave comment below. See you in the next video.